Hello guys, welcome back to my YouTube channel. So as I mentioned on the previous video that we're going to talk about DC machines. So now I want to talk about DC motors. So on DC motors, you can have three types of DC motors. You can have the series motor, you can have the shunt motor, and you can also have the compound motor. Okay. And then under the compound, you can have two types. You can have the differential compound motor. You can have the cumulatively compound motor, whereby you can also have the long shunt and the short shunt. So for now, let's focus with the series. So this is the diagram of a series circuit. So if you're having a series motor, meaning your series resistance and the armature, they'll be connected one after the other. Okay. So since it's a series motor, the first thing that you're supposed to know is that your IL is equals to I series is equals to IA. So we are simply saying the current, it is the same. Okay, and then your formula to calculate the power is still the same, V, L, and I. IL, you can also have the formula to calculate the EMF, which is going to be V minus IA. Okay, RAC. Your RAC include the combination of R series and RA, so you can have a formula that says E is equals to V minus IA, and then open bracket RA plus R series. On the other question, if you are given the brush resistance or the brush voltage, you're supposed to then also include the values of the brushes. So these formulas, they have to do with the series. Okay, and we also have what we call a shunt motor. A shunt motor means a parallel motor. So with the word shunt and parallel, it is the same thing. That's when you have your shunt resistance, which is the field resistance connected in parallel with your armature. Okay, so the first thing that we can observe with this is that the current is no longer the same. So hence, because we have a junction here, we can say IL is equals to IA plus I shunt. And if you make IA subject of the formula, it will be IL, okay, minus I shunt, whereby you can calculate your I shunt by saying V divided by R shunt. And your formula to calculate the EMF, it will be V minus IA RA. So that's how you can calculate your EMF. So you can have the series, which have to do with this calculation. You can also have the shunt, which is the same as the parallel circuit, which have to do with this calculation. Okay, so let's look on an example. Okay, but before we look on the calculation, we also have another formulas that I need to write it down. The formula to calculate your EMF. Okay, which says 2PN flux Z divided by 66. So you can also calculate your EMF using this formula, which says 2 P represent the pole pace. So if you're given a number of poles, you divide by 2, and then your N, it to be number of revolution per minute. Okay, and this will be the flux, which is in webers. This will be the armature conductors divided by 60C, whereby you see it can either be a wave winding or a lap winding. So that's the formula that you can use to calculate your EMF. So now you'll be having two different options that you can calculate your EMF using. All right, okay. So I'll just read the question that I have, and then we'll draw the type of a circuit, and then we can try to answer. I'll also share the question on the screen. So they're saying a 4-pole shunt wound DC motor draws 12K kilowatts from 240 volts. So you're given number of poles that you're given 4, and you divide them by 2, which is equals to 2 pole pairs. Okay, and they're saying it's a shunt motor, so I would advise you to draw the shunt motor. Okay, so they're saying it's having a power of 12 kilowatts. Okay, and then it's having a voltage of 240 volts. The saying supply while operating at a full load, the shunt field and the armature resistance is 150. So you're given R shunt, which is equals to 150. Okay, let me write properly. So it's 150 ohms. And the other one is 0.25 ohms, respectively. Okay, they're saying the armature is a lap winding. Remember, I said when it's a lap, your C is equals to 2P, which is 2 multiplied by 2, which will give you 4. Okay. And then the thing, it rotates. So I'm given the value of N. The thing, it's rotating at 1000 rev per 1000 rev per minute. Okay, the thing, calculate the following if the useful flux. I'm also given the flux, which is 40 milliwebers. So firstly, they want you to find the magnitude of the back EMF induced in the armature. They want you to find the EMF. So let's see how can we find our EMF. We have two ways that we can find. The first one, we can say E is equals to V minus IA RA. Okay, so I just have to check with my given information. I do have V, but I don't have IA. And I said we can calculate our IA by saying IL minus I shunt whereby, but we don't have IL, so we can calculate IL by saying P divided by V. Okay, if I divide my 12,000 divided by the voltage of 240. Okay, if you divide there, you get 50 amps. And then I have to find my I shanty again, but I shanty will say it's V divided by R shunt, which is the voltage of 240, sorry. The voltage of 240 divided by your R shunt, which is 150. Okay, and then you get 1,6. And therefore, I can calculate my IA by saying 50 minus 1,6. And then you get 48,4 amps. So hence, if I have my IA, I can calculate my E. We said is the voltage is 240 minus 48, 48,4. And then the resistance multiplied by our resistance is 0,25. And I can have my EMF, which is 227,9 volts. All right, okay, so that's A. You find your EMF. And then on B, they want you to find the total number of armature conductors. They want you to find the total number of armature conductors. So they want you to find Z. Remember, we once said E is equals to 2P flux and Z divided by 60. C, so if you make Z start with the formula, it will be Z is equals to E 60C divided by 2P flux and N. So there you can find your armature conductors, which is same as your EMF. We said is 227,9 multiplied by 60 multiplied by our C. We said it's 4 divided by 2 multiplied by 2 multiplied by the flux, which was given. They said it's 40 milliwebers, which is 40 times 10 to the power negative 3. Okay, multiplied by 1000. And then you can get your armature conductors. Okay, they get 341, 85. Okay, conductors. So that's your answer. And then on C, they want you to find the number of armature conductors per slot if there are 50 armature slots. So they want you to find number of armature conductors per slot, which is the same as Z per slot. How do you calculate Z per slot? It will be the number of conductors divided by slots. Okay, the conductors that we have is 341,85 divided by the number of slots, which is 50, and then you get 6,837. Okay, so number of armature conductors per slot, you always round off to the whole number, so it will be 7 conductors per slot. Okay, so basically that's how you can treat this question. You can also have the series one. So now we did the example of a parallel. You can then try also the examples of a series, but the question is always comes in this format. So for your electro N and 4 and also electro N5, you're supposed to understand this type of a circuit that you'll be given. Thank you for your time. I'll see you on the next video whereby we'll be talking about the compound motors.